Okay, chapter 18, air pollution and weather. So thermal inversion, that is when, for pretty much any number of reasons, a warm air layer gets trapped up where it's not supposed to be. So usually it's warmer down, on the surface, and as you go higher into the atmosphere, it cools off. There are times where cool air can kind of get trapped beneath the warm air, and that's called a thermal inversion. And when that happens, it also traps the pollutants because the pollutants will rise because they're less dense than the air. But when they get up here, it's not less dense than the warm air, so it kind of stays. And this says what every major acute air pollution episode of the 20th century has been associated with a thermal inversion because it just keeps everything right here. See how it's just like circulating back down at you rather than like mixing up here. And then also air pollution. So that's weather impacting air pollution. Air pollution can also impact weather. It can reduce visibility, reduce air quality, modify air temperature, produce acid rain, and produce abnormal rain. This is the cloud seeding. Here's an image of this is snow where the water vapor condenses on a particulate or an aerosol easier or more quickly than it would just by itself. And so when you have these little aerosols in the atmosphere, this is, I think it said Michigan, where there's some kind of manufacturing or a plant or something. And so you get this cloud seeding, but it was actually snow because it was cold. And so you had this little snowstorm that you wouldn't have had if it weren't for the air pollution. And that's it for weather and air pollution.